Definition of a limit. In mathematics, a limit is a fundamental concept used to describe the behavior of a function as the input variable approaches a particular value. The limit of a function f(x) as the input variable x approaches a value a is denoted by the symbol lim and is written in the form lim f(x) equals L x a. The limit L is the value that the function approaches as the input variable x gets arbitrarily close to the value a. The value a is not necessarily the value of the function itself, but rather a point near which the function is being evaluated. The concept of a limit is used to describe the behavior of a function around a particular point, and it is important in calculus because it is used to define derivatives and integrals. The limit of a function must exist and be unique for the function to be differentiable or integrable. A limit can be evaluated using various techniques, including algebraic manipulation, factoring, and substitution. The concept of a limit is also used to define important mathematical functions such as the exponential, logarithmic, and trigonometric functions. Types of limits. There are several types of limits in mathematics, including finite limits. A finite limit exists when the limit of a function exists and is a finite value. This means that as the input variable approaches a particular value, the function approaches a single, finite value. Infinite limits. An infinite limit exists when the limit of a function approaches infinity or negative infinity as the input variable approaches a particular value. One-sided limits. A one-sided limit exists when the limit of a function is approached from only one direction. A left-sided limit is approached from the left of the point, while a right-sided limit is approached from the right of the point. Two-sided limits. A two-sided limit exists when the limit of a function is approached from both the left and right sides of a particular point, and both the left and right-sided limits are equal. Indeterminate limits. An indeterminate limit is a limit that cannot be directly evaluated by substitution, and it requires further algebraic manipulation or a special technique to evaluate. Oscillatory limits. An oscillatory limit exists when the function oscillates between two values as the input variable approaches a particular value. In such cases, the limit does not exist. Understanding the different types of limits is important in differential calculus because it allows us to evaluate functions and determine if they are continuous or differentiable at particular point. It also allows us to define and study important mathematical functions such as the exponential, logarithmic, and trigonometric functions. Limit laws. Limit laws are rules that allow us to manipulate limits of functions and simplify their evaluation. These laws are important in differential calculus because they enable us to evaluate limits of more complex functions by breaking them down into simpler parts. Some of the most important limit laws are sum and difference law. The limit of the sum or difference of two functions is equal to the sum or difference of their limits. That is, lim fx plus minus gx equals lim fx plus minus lim gx as x approaches a. Product law. The limit of the product of two functions is equal to the product of their limits. That is, lim fx gx equals lim fx times lim gx as x approaches a. Quotient law. The limit of the quotient of two functions is equal to the quotient of their limits, provided the limit of the denominator is not 0. That is, lim fx slash gx equals lim fx, lim gx as x approaches a, provided lim gx does not equal 0. Power law. The limit of a function raised to a power is equal to the limit of the function raised to that power. That is, lim fxn equals lim fxn as x approaches a. Root law. The limit of the nth root of a function is equal to the nth root of the limit of the function. That is, lim fx1 slash n equals lim fx1 slash n as x approaches a. Squeeze theorem. If two functions are squeezed between a third function and they all have the same limit as x approaches a, then the two functions have the same limit as x approaches a. That is, if hx less than or equal to fx less than or equal to gx for all x near a, and lim hx equals lim gx equals L as x approaches a, then lim fx equals L as x approaches a. By using these limit laws, we can evaluate limits of functions more easily and accurately. These laws are also important in the study of calculus, as they enable us to calculate derivatives and integrals of more complex functions. Continuous functions. In mathematics, a function is said to be continuous if it can be drawn without lifting the pen from the paper. More formally, a function fx is continuous at a point a if three conditions are met. F exists, the function is defined at point a. The limit of fx as x approaches a exists. The limit of fx as x approaches a is equal to fa. In other words, a function is continuous at a point if it has no holes, jumps, or breaks at that point. The concept of continuity is important in differential calculus because it allows us to identify points where functions are differentiable. A function is said to be continuous on an interval if it is continuous at every point in the interval. A function can also be continuous from the left or right if it is continuous only from one side of a point. There are several types of continuous functions, including constant functions. These functions have a constant value and are continuous everywhere. Linear functions. These functions have the form fx equals mx plus b, where m and b are constants. They are continuous everywhere. Polynomial functions. These functions have the form fx equals angxn plus n1 xn1 plus a2 by 2 plus a1x plus a0, where a0, a1, and are constants. They are continuous everywhere. Exponential functions. These functions have the form fx equals x and are continuous everywhere. Trigonometric functions. These functions include sine, cosine, and tangent functions and are continuous everywhere. Understanding the concept of continuity is important in differential calculus because it helps us to identify points where functions are differentiable. A function is differentiable at a point if it has a derivative at that point, and this requires the function to be continuous at that point.